Hi there, I see that you're back, and I'm glad you are. Today we're going to be learning about mathematicians. Who are they? What do they do? We're also going to be learning about something called number sense, because next week we're going to be starting some number sense routines. So before we can start those, you need to know what number sense is. So when I ask you, who are mathematicians? You probably might think of those old guys, those white-haired guys like Albert Einstein and Archimedes and Isaac Newton, all those guys that you've heard of. But mathematicians are more than just those old guys. The lady in the middle right here that you see was a mathematician that worked for NASA in the early 1900s. I believe she's still alive. And her name was Katherine Johnson. And she helped calculate the path to get Apollo 11 to the moon and back. She did some very important number crunching. And on the right, you have Golden State Warriors, Steph Curry. Does he have to use math? Is he a mathematician? Yes, he does, because he has to calculate that arc, how he's going to get that free throw up there. But more importantly than these people right here, let me go to the next slide. You are also a mathematician. Anytime you use math to make sense of the world around you, you are a mathematician. So I want you to think about what are some characteristics of good mathematicians. If you want to stop the video for a second, you can pause it. Maybe write a few things down that you think, what makes someone a good mathematician? What does it take to be a good mathematician? And then turn it back on. All right, so these are my top 10. These are 10 things that mathematicians do. So let's look at them one by one. There might be a quiz on this later, so make sure you're paying attention. Number 1, mathematicians look for patterns. They see patterns in the numbers. Probably when you were in kindergarten, you might have learned like A-B pattern. That might have been triangle, square, triangle, square, triangle, square. And you built on from there when you learned patterns. Another thing that good mathematicians do is they draw pictures. That doesn't mean like in art class. You're going to draw a picture or a diagram, and one diagram that you probably have already heard about is a strip diagram in math. Strip diagrams can be used to show us part total, just for one example. So drawing a picture, drawing a diagram, trying to look at what the problem's asking you to solve. Number 3, mathematicians ask good questions. They want to know, how did you get that? What are we looking for? What does the question want to know? Okay, number 4, they come up with a plan. They look at it, they look at the numbers, they look at the words, and they come up with a plan. Is this a one-step problem? Is it a two-step problem? What do I need to do first? And what would I maybe need to do after that? Okay. The next thing they do, super important, that I see a lot of 5th graders not do, but it's not a hard thing to do. It's something you want to get in the habit of doing, checking your work. The 2 words I've written beside there are inverse operation and reasonable. So inverse operation, the word inverse means opposite. So if we were doing a addition problem, the way we could check it, we know that addition and subtraction are inverse operations. They're in the same fact family. We could go back and check our addition problem by doing subtraction. Same thing with multiplication and division. We can use multiplication to check division and vice versa. The question at the end where I put reasonable, what that means is we want to ask ourselves, does my answer make sense? So the way we do that is we kind of think, when we're talking about whole numbers, we know if we're adding numbers, our answer should be bigger than the add-ins, the numbers that we started with, right? We know if we are dividing, we need to think about we would expect our answer, our quotient, to be smaller than our dividend or the total number that we started with. So looking at your answers and asking yourself, does my answer make sense? Okay, so number 6 says, good mathematicians can explain their work and defend their answer. So we're going to get more into this later, but I don't want you to just tell me, I got this answer. I'm going to ask you a lot. You're going to hear Ms. Wissel ask you, how did you get that? That's defending your answer. I'm going to say, how did you get that? You may get it one way and somebody else may get it a different way, and you both could be right. You both could have the correct answer and you arrived at it different ways. That's being flexible. We'll talk more about that later. Number 7 is one of my favorites. Number 7 says estimate. Good mathematicians estimate. Estimate is making the math easy for yourself. It's taking numbers like, let's see if we were going to multiply 19 times 28. Well, I'm not going to do 19 times 28. I'm going to think of 19 like 20. I'm going to kind of round it off. And I'm going to think of 28 and as 30. And then I could get a rough estimate because if I look at my two numbers in the front, a 2 times a 3 gives me a 6. And then I have those 2 zeros on the back. So 19 times 28 is about 600. All right. Good mathematicians take their time. They do not rush through things. Getting an answer fast is not what we're looking for in 5th grade math. We want you to get the correct answer and be able to defend it, explain how you got it. Number 9, I've already touched on this a little bit. Good mathematicians realize that there is more than one way to come up with the right answer. And number 10 is an amazing one. Good mathematicians are not afraid to make mistakes. We realize that mistakes are a starting point. When we make a mistake, that's a jumping off point. It means we can grow and learn. If we don't make mistakes, we probably won't grow. That's how we learn things and we get better at things. All right, let's go to our next slide. So now we're going to move into what is number sense. You've probably heard your teachers talk about, they say the word number sense, and you may not even know what that means. What number sense means is, it's the ability to understand and connect to numbers. It's not using paper. It's just being able to do the math, a lot of math calculations in your head. So, and we'll talk more about building our number sense, ways that we can do that. Number sense is the ability to think fluently about numbers and being flexible in your approach, realizing like that's not the only way I can get to that answer. A lot of times when we do a number talk, I'm going to say, how did you get that? And if you have one way, I may ask you, okay, good, you have that one way, keep it in your brain. Think of another way. Could you have solved it a different way and arrived at the same answer? Number sense means being able to talk comfortably about numbers. And number sense is the ability to estimate answers before calculating and assessing how reasonable your answer is. All right. So number sense routines. Talking about math helps us develop a deeper understanding of the concepts that we're going to be covering in math. So we have these things you might have seen before. They're called sentence stems. Sentence stems are little phrases that have words left out. A sentence stem that you might use would be like, I predict that my answer will be about, and then you would give a number. If you were having a number discussion with someone else and they gave an answer to the teacher, you could add on to that by either agreeing or disagreeing. And there's a sentence stem for that. You could say, I disagree with Keegan because, or I agree with Chloe because. Okay, so those are our sentence stems for math that we're going to be using this year when we have discussions, when we participate in discussions in Canvas with other students. I'm going to want you to use these type of sentence stems to create your argument, whether you agree with how they solved it or didn't, and argue how you got that answer, defend it. Okay? All right. So those of you who we are recording this, you're not going to get to actively participate in this, but we can kind of talk about it. A number sense routine that we use, one of them is called Which One Doesn't Belong? So I want you to look at these 5 dice. Actually, it would be 5 die because it's plural. You look at these dice and you could ask yourself, which one doesn't belong? Well, I bet you picked the blue one, didn't you? I think it might be the blue one because it's a different color than the rest. But guess what? Somebody else might not have thought that. They may say, I disagree. I think it's the one in the top right corner because that one has a 1 on it and the rest of these show 5s. So I might think that it's this one. Well, another person may even think that it's this one in the top left. Why would somebody maybe think it was the one in the top left? What's different about that one? It has a written number on it, whereas all 3 of the other ones have the number represented as dots. So you guys get the idea. It's just knowing that math is open. There could be different answers. There can be different at our answers. All right, let's see if I can get to the next slide. All right, we're going to be doing that in class, and I think that is it. So let me go ahead and stop my recording.